All right, guys, welcome back to our 9.2 day 2 notes. We're going to get these done here. We got 2 examples to go through, and you should be good to go from there. Okay, so in this example, we are going to be talking about basically the same thing we did yesterday. It's just that we're going to be adding in one other example here on the next problem. So this problem, we're talking about a biologist studying populations of bats over years. Okay, so at the beginning of this graph, it's basically saying that years X in bats in thousands of Y started 7 years ago. So at X equals 0, that was 7 years ago, and then now at year 7, there's a certain bat population. Okay, so we're going to do the same thing we did yesterday in terms of graphing. I'm going to slide this table down here so that way we can see the numbers when we graph. Move the graph up, maybe that would be helpful. So just to make sure that we're all remembering the stuff from the video yesterday, is that we're going to make a scatter plot with the data in our graph, and then we're going to pick a line that we think best approximates what the data shows us. Okay, and that line is going to go through most of your data, but it doesn't necessarily have to go through every single point. That is kind of the important part here. Okay, you don't necessarily need to have it go exactly through the y-intercept, but that's totally your call. Okay, so as you can see, we're putting the points here on the table. You should be able to figure it out, even though you can't see it in the video here, that this line that we put the first point on is at X is 0, and then we're going down here, and once we put those points on, then we can go and figure that out. Okay, so as you can see, when we go through graphing this, you can start to recognize that there is a pattern or a trend here. Okay, and since it is a negative linear trend, which is what we talked about in 9.1, we are able to draw a line of best fit. Okay, so I drew this line here, and it's the best that I could make it here, but it is pretty darn accurate, and there are quite a few points to choose from here as far as what we need on our graph. Okay, so what we're going to do now is we're going to write that equation. Okay, this is probably going to be the trickiest part for some of you because you're not used to using slope or the y-intercept that we have been doing in the past. Okay, but you do need to, again, get it in slope-intercept form so that way we can easily find future information, because that's the whole purpose of why we're doing this this section, this standard. Okay, normally this would be something that we would be assessing on the big sheets of paper, but since we can't, this is the best that we can do. Okay, so in order to find our equation, we need to find what? 2 things. Who can tell me? Okay, we need to find the slope, and we need to find the y-intercept. So as long as you can understand that we are using this in slope-intercept form, guys, this is going to be a pretty straightforward problem, and this is what we're going to do on the next one as well. Okay, so in order to write equation in slope-intercept form, we do need to get that slope. So we're going to pick 2 points. Okay, so these are the 2 that I picked. It doesn't necessarily mean it's the 2 that you have to pick, but the biggest thing you remember is that you were picking points that are on the red line. They are not necessarily points that are going to be just randomly throughout the table. Okay, you just pick any 2 points on the table. They have to be points that are on the line, and these are the 2 that I chose. Okay, 270 and 254, and those y values are in thousands. Okay, so what we're going to do is we're going to take our y2 and our y1, and we're going to subtract them, and then do x2 minus x1. So I get 254 minus 270 over 4 minus 3. Now, what should you expect in terms of what type of slope we should get? Well, since we're dealing with a negative slope, we should be getting a negative number. So I got negative 16 over 1, which is simply negative 16. And now we need to find our y-intercept. And if you see on the graph, it is going through that point at 327 when it crosses. So we put those together. We've got y equals negative 16x plus 327. Okay, that is the big equation that we are trying to get out of this scatter plot. That is what I'm trying to get out of you guys. Okay, now we're going to use this to answer the question below here on modeling. So we're going to now use this equation. Once we scroll down here, we're going to use this equation to predict a future amount of data. Okay, so once we get that up there, I do want to switch that. So we were saying it was going to be at year 7. That is currently right now. Okay, it says in the beginning of the question, if you can see it on your page, okay, it wants 3 years from now. All right, so I guess I'm not going to scroll it up on the screen, but we want to figure out when x is 10. That's 3 years from currently, which is 7. So I have negative 16 times 10 plus 327, and that should give you. All right, so looks like we're not going to be able to get the answer up on the screen, so I'll just tell you what it was. If we add negative 160 to 327, you should get 167,000. So again, as you guys can see, it's very easy for us to now, once we have that equation, figure out future data that is not necessarily in the recorded data shown. And that's really important in pretty much anything that you can think of that involves collecting data in a linear pattern. Okay, so as we've been using and as we've been talking about, a line of fit is used on a scatter plot to plot close to most of the data points. Again, the keyword is most here. It's not exact, not all, it's not everything, it's just most. Okay, it's used to help estimate data that goes on a graph. All right, so if you need to go back and pause that to write that down in your notes, please do so. Otherwise, we're going to get going here on the example. So we're talking about the depth of a river after monsoon season. Is that what that was? Yes, so depth of a river after monsoon season. Okay, so we're going to make a scatter plot of the data, and we're going to draw a line of fit. So what we need to do is we need to actually label the graphs here, because this is a blank graph. So this is going to be something that you'll have to do on your own when it would come to an assessment. I might have made you pick one, but for the most part, I might have just had you copy this along here. So as you can see, we're putting those on there. I'm only putting increments of 1, because if you see on the Y column, the highest number we have is 20, and then it starts to decrease at small intervals. So I'm just going to increase everything up by 1s, and then along the x-axis, we're going to put 1s as well. So it's going to be 1, 2, 3, 4, all the way. Now, for some reason, my screen on this video is not showing you the bottom of the screen. Okay, but again, since we're decreasing this by 1 here, you should be able to see most of what we have up. Okay, so as you can see, there is another negative linear trend here after we put up the video. Okay, so once we get that up there, then we're going to draw a line of fit, as it also says to do after we make that scatter plot. So we're going to put our line again that fits most of our data. Okay, now the bulk of our data is actually in the second half here. So after x equals 2. Okay, it's important that you are able to recognize that it doesn't necessarily need to go through the point that starts at x equals 0. Again, what we are going to need then is y equals mx plus b to write the slope of our line. So we need to pick 2 points that are actually on our line. Okay, so I'm going to pick the 2 blue points here that you can see on the graph, and those points are going to be definitely ones that might not be the same ones that you have, but they are going to be the ones that I'm going to pick for you, so that way you're able to easily find that slope. Okay, so the 2 points we're going to use are 5, 10, and 8, 5. All right, we're going to do 5 minus 10 over 8 minus 5, which is going to give me negative 5 over negative 3. Or just, sorry, over 3. The equation sign got to me. It should be negative 5 over positive 3. Okay, and then since my point is going through 18, it's going to be a b value of y equals 18, or sorry, b equals 18, and then we're going to have our equation of y equals a negative 5/3 x plus 18, and that is your equation here. I do not want to do part C for this one, so you can skip that, but we are going to then now figure out what it would be for the next value of x equals 9. Okay, so we're going to plug that in. Cross cancel, 3 and 9 can be divided out by 3, so I get a negative 5 times 3, okay, and that's going to be negative 15 plus 18, so y should equal 3 based on our data model. All right, hopefully that made sense. I know we went through that really fast, you guys, and I want to make sure that you guys understood this. If you need to go back and rewatch how we did the first one is really more important. The second one is pretty much the same thing. It's just we had a little bit different data to deal with, okay? I hope you guys were able to figure that out. Shout out to Rosie Oldenburg Garcia, who did actually point out in the last video that there was a mistake on one of the problems. It should have been the answer of 34 inches instead of 33. So if you see that, please make sure that you don't write that down and double check your math on that, okay? All right, hopefully you guys have a great day, and I will be posting the big ideas here shortly.